The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. Welcome you all to the Tech Gig webinar. Thank you for joining the session today. The topic of today's talk is Smart IoT Devices. It will be an hour session with around 40-45 minutes for the presentation and the remaining time for the Q&A. So if you have any questions, please send them to us using the question tab on the GoToWebinar control panel. I am Vedant, the moderator of this session, and it gives me great pleasure to introduce you all to a guest speaker, Kush Mishra, Chief Technical Officer, SenRa. Kush is a Chief Technical Officer at SenRa and responsible for all product development initiative as well as strategic partner ecosystem growth. Kush has been responsible for bringing several customer IoT products in the global markets. So without any further delay, let me introduce you all to a guest speaker. Over to you, Kush.
Thanks, Vedant, for the lovely introduction. It's a pleasure to be part of this webinar, and I hope I'm able to bring in some valuable insights. I'll start off and set the stage by introducing myself, apart from what was already discussed by Vedant. So I'm a graduate from Indian Institute of Technology from 2009 electrical batch. I've worked for several years now in the IoT domain. One of my initial work experiences started with Bosch, which is a German automotive company, back in 2011. I was part of a corporate startup called Bosch Connected Devices and Solutions as one of their founding team members. I worked there for around 5 years, post which I did my MBA from Indian School of Business in Hyderabad. Um, I started my own company directly from MBA, and recently, last year, I joined SenRa as their CTO. A bit of introduction on what SenRa does. So SenRa is a low-power wide area network operator based in India. We mainly concentrate on LoRa, LoRaWAN, IoT networks. SenRa is wholly dedicated to the global open standards for LoRaWAN. SenRa basically provides low-cost, long-distance, and low-power wireless connectivity for businesses and for governments, agnostic of industries. We are also a contributor level member at the LoRa Alliance, which is responsible to set the specifications for each country and the overall technical specifications for the technology. Starting the discussion today, I really shortly want to discuss what IoT means for the general public and what the technology is all about. Recently, there has been a lot of buzz around the keyword IoT, and I think it makes sense to just break it down into components. So essentially, an IoT system composes of devices, a network, and an application. The devices are based on sensors, actuators, as well as location trackers. By sensors, you could have a multitude of sensor technologies, MEMS-based sensors, chemical sensors, gas detection sensors. The MEMS sensors could further be broken down into accelerometers, magnetic sensors, gyroscopes, pressure sensors, acoustic sensors, so light intensity, luminaire sensors. The actuators would really be responsible to convert an electrical signal into a physical motion. This could be triggered by an electric current, or it could be a magnetic field causing things to move. So actuators would be mainly used for example, door locking or igniting a motor, things like that. The third category of end devices would be location trackers. And how is it different from sensors and actuators? While the former two either sense their surrounding environment in one manner or the other and actuate physical devices, trackers instead would really just be positioning the devices. It could be for a use case that tracks an asset. It could be for a use case that tracks a person, um, or even a small thing such as a car key. So these are all kinds of sensors. One thing that is common across all these end devices is that these devices speak to the internet, which is the most crucial part of an IoT ecosystem. So how do these devices talk to the internet? Well, there is a communicating chip present on each device. The communicating chip could be a Wi-Fi chipset. It could be a LPWAN chipset, a LoRa-based chipset, for example. It could be a GSM chipset, so the device can talk to the internet directly and gets assigned an IP address. It could be anything from a Bluetooth to NFC-based communication. So multitude of communication technologies. What it essentially boils down to is data routers. So a device would talk to a receiving entity that would receive the device package and then transmit this to internet. And on the internet side, you can have options. So a usual cloud infrastructure would compose of a network controller. In case of GSM, for example, these would be the likes of telecom operators such as Airtel, Vodafone's, Ideas. In case of LoRa, it's companies like SenRa. Uh, um, in addition to that, there would be an application controller. Again, in case of GSM, it could be a municipal water corporation's application server. It could be a smart parking application server, a GPS tracking application server, and so on. There could also be third-party security controllers or security servers which authenticate every message sent from the device to an application, as well as control which devices get access to the particular network. Pivoting a bit from what the device ecosystem, the network ecosystem, and the application ecosystems look like, I want to quickly discuss what kind of verticals a device manufacturer can target when he wants to approach the IoT market. So it can be essentially broken down into these three: B2C, B2B, and B2G. Um, it stands for consumer-based products, business-oriented products, and city-scale products, which could be more or less government projects. India's IoT devices market size is really expanding. It will increase 7 times from about $1.3 billion market last year in 2017 to about 9 billion devices by the end of 2020. Endless possibilities with device manufacturers. I'll just give you a brief overview of what each of these mean. The verticals could be environmental monitoring. This could be pollution sensing for a city like Delhi, which is very crucial. About 3 months out of 12, there is a severe pollution hazard, and we want to keep a real-time check on what's the particulate matter, what's the NO2, CO2, CO levels in the atmosphere, what's the SO2 levels. Safety and security is another big vertical. Recently, there has been pushes from city corporations to incorporate security features in public transport. For example, there is of course agriculture, which is one of the biggest employment sources in India. The market is really huge. We are seeing several different kinds of innovations in the agriculture space. People have been trying to come up with devices which detect soil humidity, pressure. People have been trying to detect the environment conditions and the weather conditions, combine them together and operate the cultivation and the irrigation cycles accordingly. So a lot of scope in agriculture as well. Then you have healthcare and diagnostics, which is really picking up, but still it's in a nascent stage. I would say more or less because of the government regulations around healthcare. The devices really need to be adhering to particular standards since they are they are handling a very critical customer portfolio. There are, of course, smart utilities, which means smart water meters, smart gas meters, energy meters. These could be based on a variety of applications, and really have a city-wide scale. Asset tracking, as I mentioned earlier, it could range from geofencing to asset movement, fleet management, people tracking, or even things like small objects lying around the household. Facility management is again a big vertical. This would essentially mean building management, smart campus style deployments, ports, power, mining industries. I hope I've made clear there is a variety of use cases possible, and there is opportunities which lie untapped in each of these. Let's boil down to the three kind of verticals that we earlier discussed, three kind of industries. The consumer industries. So what does it essentially translate into? We have it's a good entry level for any new device manufacturer. We have consumer convenience gadgets, which are oriented towards making the life of an end consumer easy. This could be a smart door lock, a smart thermostat that could be controlled from your mobile phone, smart appliances such as smart refrigerator, smart washing machine, things like Amazon Alexa that have now really revolutionized how language is processed and gets converted to integrating with Amazon ordering infrastructure. So these are certain new things that have been really coming up into the consumer IoT market. You also have the BLE and GPS-based trackers, several small companies which let you track your keychains to your wallets, your mobile phones and such. Coming over to the enterprise use cases, we believe that the next big industrial revolution will be brought about by data. How do we collect this data? Could be in a multitude of methods. Usually, enterprise use cases are also referred to as Industry 4.0 or Industrial IoT or IIoT as it's usually called. Two prime verticals that have been gaining really big traction, I'll discuss in the next two slides. So smart factories. A smart factory would be composed of a lot of existing legacy infrastructure, so smart factory floors. You will have CNC machines, you will have conveyor belts, assembly lines, robotic arms, and so on. How you can tap this market is there are things you could do with temperature sensing, vibration sensing, oil level monitoring. All these sensors would usually translate into predictive maintenance data. If you have a robust data analytics platform which could convert your data into meaningful insights over a long period of time, that's something really valuable, because as much as 40% of the raw material for some of the devices could be power. And sometimes you want to monitor outages of machinery, outages of or overconsumption of power through certain machines. If the oil level of transformers go down, you want to monitor that remotely. So a manual check on all these parameters would be very time consuming, very inefficient, and sometimes totally impossible. And that's where the power of IoT kicks in. So we are seeing a lot of new innovations in the field of CNC machines, sensors like temperature sensors, oil level sensors, vibration, noise sensors, several new applications coming into these fields. Controlled VFDs, smart meters, which can gauge every machine's consumption of water or electricity. You also have edge connectivity solutions, which literally mean how to convert data coming in from the existing SCADA or DCS systems on Modbus or CAN protocols, how to convert them into RF, and without even modifying the existing layouts of machinery on a factory floor, how you can retrofit a small piece of device on a machine and start getting data from this. It could also be a retrofit on a PLC panel or serial IO ports. The second layer in smart factories is the network infrastructure layer. So usually, typically, if you're not getting a good network signal inside a smart factory, you will not be able to go to a telecom operator to ask them to put a telecom tower next to the factory. These are usually cases where local LANs are beneficial, or you have a wide area low power network. So there's a huge scope in companies who want to get into that domain as well. Then there is the cloud solutions based on Microsoft Azure or Google Cloud or AWS. These are usually provided in a PaaS model. And lately, there has also been a surge into blockchain offerings combined with IoT. So how you can have a distributed ledger by combining field data and having a distributed ledger throughout your supply chain. I'll switch over to two use cases. The second one is the smart logistics now. Smart logistics is again a big vertical, and we've seen a real hotbed of startups in this domain. It's an estimate that $1.9 trillion revenue can be generated over a 10-year time frame starting 2015. So until 2025, the total overall value generated would be approximately 2 trillion. There are essentially four pieces in the entire supply chain. Starting from capacity management, which essentially means when a good or a cargo comes into or checks into a warehouse, you want to physically attach an ID to the cargo, and you want to avoid as much as human labor as possible. A general person, while he's traveling inside a big warehouse like an Amazon warehouse, would be traveling 7 miles in an entire day. That's a lot of walking, that's a lot of manual labor, and a lot of this could be avoided with robotic process automation, with sensors deployed in the field, with automated barcode and RFID scanners. So a lot of stuff could be done in capacity management. The second step would be planning and reporting. So what that means is once you have the good in-house, you still want to know whether there are thefts, whether the goods have been tampered with, where is the exact good in the warehouse, which shelf, what's the location. And it's a good market for tracking inventory devices. The third step is route optimizations. Route optimization again is a hotbed of startups. We have seen a lot of startups coming up with fleet management softwares, congestion prediction softwares, GPS-based tracking devices, which also have a lot of sensors embedded in those devices that could tell you the health of a truck while it's transporting your logistics. The step 4 would be fault detection and prediction. So when you're managing such a huge facility like a warehouse, you would want to optimize the energy consumption, and you would also want to optimize the machine downtime. And that's where a lot of power of IoT from the previous slide of a smart factory floor comes into picture. I'll discuss with you one use case that we saw approximately 3 or 4 years back when I was working with Bosch. So Tirupur near Coimbatore, it's a big hotbed of textile mills in India, and in one of the cases we saw that the textile mills one of the raw materials of the textile is power by running spindles, running machinery. And in case there is a faulty machinery, it could be a dislodged belt or a pulley that's not fit properly, or a motor that is worn out from years of usage. Approximately 40% of the cost of conversion from cotton to yarn is taken up by electricity. So if one of these is a problem and you are not able to pinpoint in the real time from where this electricity consumption is going up, you sometimes would get a shock at the end of the month in your bills. And if 40% of the cost of your cost of conversion into yarn is the electricity, that could be a really big element of loss in the ecosystem. So manual inspection is obviously not going to help, and in some of the cases you cannot actually test a machinery's electrical consumption. So what the factory did was installed smart energy meters on every piece of machinery that they could, and it's approximately 200 to 300 machinery. So 200 to 300 data points in a single factory floor, and they combined this real-time data with analytics. So a cloud-based system could monitor what was the past uh, uh, patterns of electricity consumption during the lifetime of a machinery, and they compared it against the real-time values, and they were able to predict if a machinery is guzzling too much energy, which indicates in turn a faulty piece of hardware. So this resulted in a lot of power savings, and as I said, 40%, up to 40% of potential piece of the cost of the raw material. Coming to city scale use cases, well, there are several of city scale use cases, and recently with the government push towards smart city, the channels have really opened up, and transparent e-tendering and partnerships and pushes to startup and make in India have really opened up a lot of opportunities for startups. We are seeing several specific verticals gaining more traction than the others, like smart water meters, smart gas meters, irrigation and waste management, traffic monitoring and congestion avoidance, and route optimization across the city. I'll discuss a few of these use cases through infographics that we prepared. So this is an illegal parking scenario, for example, for a city like Delhi or a city like Bangalore, one of the fastest growing cities in the country right now. Traffic has been really unorganized and unstructured. If a startup is able to bring structure into this chaos, that would be a huge value proposition. And we have recently started seeing devices who are trying to arrange or address the issue of illegal parking. So this is one use case. You can see when a car comes over on top of a device which is installed at an illegal parking slot, you get an immediate notification. So the local traffic police gets an immediate notification that the illegal parking slot has been occupied, and they can immediately go down, do the challenge, and that's an additional source of revenue for the traffic police and really a big deterrent for illegal parking. The second one is organized parking scenarios. This means that whenever you enter a crowded area, you'll get an immediate notification or you'll get an immediate feedback of how many free parking slots exist in that area. This also means that you can plan your trip accordingly. You can plan your parking accordingly. You can plan to go to a certain area at a certain time of the day, or not go at a certain area in a certain time of the month when it's a festive season. So several kind of interesting insights could be brought from the data collected over a period of time and from the devices themselves. We've also recently started seeing smart solid waste management as a being really pushed from the government side. These are, for example, there's one device manufacturer who's trying to sense what is the fill level of waste bin and show this to the municipality. The municipality in turn can optimize their route when they want to go out and collect these garbage cans, and they could also see which garbage cans are being used more than the others. So they are able to plan out their garbage bin deployment throughout the city more effectively with this data. Again, smart water meters, it could tell you a lot of real-time insights. The city water corporation could really plan out their timings of water in certain locations in the city. They could have a transparent billing cycle. The customer has a transparency towards what's the amount of water consumption throughout the month in real time, and that can really help him plan for it. and not get a shocker of a bill at the end of the month. Also, it saves money for the smart city officials to not have to send a person to collect the smart water meter data from house to house. That's really time consuming, effort consuming, and suboptimal. We also have a strong push on smart streetlights vertical. This would mean at a particular time of the day, the streetlights turn themselves off. At a particular time of the day, you get to know what's the luminosity, what's the kind of brightness levels you need from the lights. Also, what's the energy consumption coming from the streetlight. This data could be reported to the server as well. So we've discussed a lot of different kind of use cases till now, several spaces where new startups could start looking into. Let's discuss how do they do that, how do they go about thinking about how to enter which market, how to evaluate a market, and how do they build devices that are relevant for that problem. So I would simply put it as a never-ending loop. A product development is a phase-wise process. It can start off with market research. It can what I mean by market research is you need to go out as a device manufacturer and talk to your customers as well as existing players in the market who have seen the ecosystem grow, who know the exact pain points that need to be addressed, and this helps you get a sense of the general timing to the market. So what kind of is it the right time to go to the market with this kind of solution, and what's the exact willingness to pay for an end consumer. This in turn leads to you being able to test the feasibility of an end device. So whether the device is feasible to be built in the given time frame and at the right price point. There's also the technology that you need to take a call upon. Some of the technologies might be an overkill and might add to the bill of material if you're not careful. So for example, if something can be located which doesn't need an exact and precise location, you can use LoRaWAN's geolocation to triangulate the position in 30 to 40 meter accuracy range. If you really need a GPS level accuracy, you want to go with a GPS device. Then you kind of balance out the battery requirements versus time to fix and the kind of location accuracy that you need. So you do not want to over-engineer a product or under-engineer from a requirement point of view. And then there's of course the testing. A good idea would be to do an A/B testing, which means test with 20% of your customer base, get the feedback, incorporate that in the next development cycle, create add-on services to create recurring revenue streams, and get repeated customers. I'll quickly give you a brief comparison on various technologies that are out there in the market, and this is more from a technical point of view, but I'll try to keep it generic so that it can be easily understood from people who are not from this background. So usually with devices, there are three ways you can communicate, and it's really a use case specific choice. And I'll explain that in a bit. So the first one is a local area network, a LAN. These could be devices on Wi-Fi, Zigbee, or Bluetooth. The data rates are really high in this use case. The ranges, however, are very short. By short, I mean you would know what a usual connectivity range for a Wi-Fi router is. It would be your room and the next room, so probably something like a 250 feet radius around you. The range is not that big. The battery life varies from use case to use case, but in general, it requires a bit more battery. The cost is a bit high. The kind of use cases you can target is smart TV, audio and visual use cases where you need to stream YouTube video, for example, or you need to upload a lot of information on a network server. Or it could be a local Bluetooth where you want to just communicate over a 1 meter radius or a 2 meter radius. The other kind of technology would be cellular. This is more an outdoor technology, and what it offers to you is high data rate and a long range. But the kind of battery life that you expect from cellular is really short. You can see your usual typical smartphone getting exhausted out of battery in less than a day or 2 days. The usual use cases would be smart grid, where the devices are connected to a grid where you don't have a big battery requirement, but you have an infinite amount of power already coming in from the grid. Uh, the other use cases would be CCTV. Again, they don't run on batteries. Asset tracking, which run on batteries which are connected to the truck batteries. And again, then personal communication. CCTV, smart grid, and personal communication are very high data rate consuming applications. And you can clearly see that cellular is a way to go about these kind of technologies. The third category, which is I would say not so mature in the Indian market right now, but it's really picking up, is LPWAN or low power wide area networks. I'll come to what it means in a few slides. The ranges are very long. There is a link budget for those of you who are aware of this concept. The link budget can be in excess of 150. Um, The range of LPWAN router in rural scenarios could range from 15 kilometers to up to 25-kilometer radius around it. The kind of battery life that you see from, for example, water metering devices would be approximately 10 years onwards and could go as high as 16 years of battery life guaranteed. So it's a excellent use case for IoT. The cost is really low because you don't need expensive components to be put on the PCB. The typical use cases would be monitoring anything to do with long battery life and not something which is connected on a grid. So it could be a monitoring use case, a smart water metering use case, or a gas metering use case, temperature monitoring, location tracking, asset monitoring. Uh, so lot of different kind of use cases, and I'll try to get into how this is opening up new device verticals and new kind of use cases out in the market. A small comparison chart over different communication technologies. So on the vertical axis, you can see the baud rate, which means the data transactions. On the horizontal scale, you can see the ranges. So the Wi-Fi and Bluetooth, you can clearly see they support a high baud rate, but at a very low range. Then you have a low baud rate and low range solution, which are usually Zigbees, Bluetooths, NFC, thread protocols, and such. You have cellular, which has large range and a large baud rate, but low battery life. And then you have the LPWANs, which can comprise of weightless P, LoRa, Sigfox, NB-IoT, and such in general. One thing which is a bit out of scope for this discussion, but I still want to touch upon, is the security in IoT. So ideally, every device by nature is networked, and what it means is it opens up doors to a hacker to invade the systems, to interfere with billing mechanisms. It also opens door to economic espionage and terrorism activities and such. So a lot of these things, for example, could be hacked, and the device level security, the application level security, data encryption, and the network level security are really important components of the IoT ecosystem. A few of the examples are listed here. What happens if you hack an electrical distribution system? You could black out an entire city and cripple the entire city's infrastructure. What happens if you are able to hack one of the devices which connects to the air traffic control system? If you could, it could result in big accidents. What if a medical equipment is sabotaged in a big hospital? Again, I mean, these are really serious breaches of security, and it's just an eye opener on what can be out there. Again, this also opens opportunities for startup to get into IoT security domain, and this is a big vertical as well. So coming over to why LPWAN and how it's trying to change the market recently. Well, experts have estimated that more than half of the IoT market will be best suited to LPWAN connectivity. What is an LPWAN? An LPWAN is a low power, wide area network. It offers bidirectional communication, which could be acknowledged or unacknowledged. It operates in a simple star topology where a central router is talking to multiple devices directly. One of the flip sides is the data rates are lower. Um, it doesn't support a high data rate application. For example, you will not be able to stream an HD video over YouTube using an LPWAN, but you'll be obviously able to monitor sensors which are transmitting data every 10 minutes, 15 minutes, or every hour, every month, things like that. It's really low cost. It has a very extended battery life and long range, which I just discussed recently. There is no mesh involved and there are no repeaters involved in this. It's the simple star topology keeps the network simple. Every device talks to directly the network and there is no intermediary. So it saves on a lot of battery as well. It's ideal for IoT and M2M use cases, industrial automation, low power applications, battery operated sensors, remote area applications as well, like agriculture, mining use cases, ports, refineries, power stations, and verticals like those. Four-pronged advantage: ultra low battery life, wide area connectivity characteristics, really low cost chipsets and devices, and low cost of network infrastructure deployment. A competitive differentiation between LoRaWAN, Sigfox, Ingenu, cellular, and LANs. I'll try not to spend too much time on this, but LoRaWAN operates in the unlicensed spectrum, which means that if we don't have to buy a licensed spectrum from the government of India or try. Mobility is supported. You can roam in a LoRaWAN network. Bidirectional communication is inbuilt. Right, and it has a possibility to really scale your use case. So with a single city of New Delhi, it can be covered with approximately 60 base stations, for example. That really gives the whole city as your playfield. Which means if you have a smart water meter solution which you want to bring to the smart city New Delhi, you automatically have the whole city covered, and that brings in an inherent scalability to your solution. One thing I forgot to mention was the LoRa Alliance. So the LoRa Alliance is an alliance of more than 500 members currently, including the likes of Comcast, Google, IBM, Cisco's of the world, Texas Instruments, and such. These companies are really pushing LoRaWAN, and the beauty lies in the fact that it's an open standards protocol. So a startup can really just take up a LoRaWAN 1.0.2 stack from GitHub and really start developing solutions and try to test them on our network. Who benefits? System integrators. They get a great big diversity of solutions. Some of the use cases which were not possible earlier are now possible. For example, campus style deployments. Use cases like agriculture, where you don't have an electrical supply and you don't have, or you get a very weak GSM signal in a big agriculture field, are now possible with LoRaWAN. It can really benefit a large industry or a campus by distributed monitoring and actuation. You don't even have to reach out to a telecom operator to set up that infrastructure. It's a very low cost of deployment of network for us. The revenue generation, again, directly possible now. How it benefits a product manufacturer. Well, it expands the scope of offerings. So use cases which were not possible earlier are now possible with LPWANs. It offers an out-of-box connectivity, usually typically a device which is on the LoRaWAN network will be always active. If you are looking at battery lifetimes of 10 years, you can really get out of the box connectivity from these devices. Just activate the device and the device starts talking on the network. Some of these things I just discussed. So it unlocks new market potential by lowering the cost and increasing the flexibility of solution deployment. It can disrupt the markets for wide area connectivity by allowing for entry of new kind of providers. And LoRaWAN can act as a significant competition differentiator. You get an inherent scale, and for device manufacturers who did not have smart devices earlier, this is a new opportunity coming up in the ecosystem now. I'd like to present a small summary of our discussions. Well, so we are a contributor level member of the Alliance, and we definitely aim at bringing in a pan-India network in a few years. With our extensive knowledge and experience, we also want to enable the developer ecosystem. We give up to 10 free devices. So if you are a developer who wants to explore LoRaWAN, what you'd essentially need to do, for example, would be get an Arduino kit or get a Raspberry Pi kit, and essentially buy a LoRaWAN chipset, piggyback the chipset on an Arduino kit, take the LoRaWAN stack from GitHub, write a sample use case. It could be a small temperature sensing device, and benefit from our free tier, which means you can test up to 10 devices for free on our network, and register your devices on the portal, and start experimenting with data immediately. So this is something that we are really looking forward to now. A lot of new developers, a lot of new educational institutions, student communities are really bringing up these good solutions, and it's really great to see startups, benefiting from what we are providing. So with that, I'll open up the house for further question and answers, and over to you, Vedant, to bring up questions. I'll be happy to answer them.
Thank you so much for this insightful presentation. You may take up the questions now that are appearing under the question tab.
Okay. Okay, so a lot of questions. Let's start answering the first question. So the first question is from Vatsal Shah. The question is, why did you choose LoRa in the place of Zigbee or Wi-Fi, etc.? Well, I think I in part answered this question just now. So LoRa is really a game changer. What it can do is provide a wide area network and provide it to a host of different kind of solutions agnostic of the use case. What that means is it could be a device in the same area of, for example, Bangalore. If we cover an area, and if you're a device manufacturer who is working on smart temperature sensors, and you want to deploy it in a 8 to 10 kilometer radius in a locality, for example, in Marathon. Well, you can already start doing that without depending on a Wi-Fi topology. If you are if you are supporting Wi-Fi with your devices, you would need to depend on Wi-Fi routers being deployed every 200 to 300 feet, and that would really limit your scale of deployment. So with LoRa, there's an inherent scale that comes in for smart city deployments. I hope that answers the question. Another question is from Alok Tripathi. The question is what the car parking locator and RFID used in car for toll plaza are the same type of devices used in IoT? Well, a good question actually. The RFID is usually used for detecting IDing a car. A car parking sensor, on the other hand, just tells you whether that parking slot is occupied or unoccupied. So an RFID, yes, it could be used, and it's interesting how you're starting to think about these things. So if you have a passive RFID tag on a car, and if you have an RFID reader installed from where the car is passing, yes, you could identify the car and update this information to the parking lot management company. It would be really useful for them to see how many cars are entering, which cars are entering, and where they are going, essentially, right? So yeah, good use case, good thought process. Some of the questions I will have to skip because they're not really clear. Again, a question from Vatsal Shah. We are working on smart home and office devices. So what would be good options according to your experience? First of all, I'm really glad you're working on smart home and office devices. I'll share with you the kind of devices I have seen out in the market. Um, right now, a lot of companies are building a lot of developers, society developers are building smart societies, smart homes, and smart infrastructure in those smart societies. So one use case which is coming up is uh, you want to detect people coming in illegally in societies. You want to detect people opening windows or opening door locks, so security breaches, trespassing, and those kind of scenarios. So we have seen a lot of device manufacturers coming up with smart door sensors which detect opening and closing of doors, and can intimate that information to you on your mobile phone via a network server or an application server. We are also seeing occupancy sensors for smart offices where people sitting on a desk or not, this information is conveyed to the management. We are also seeing a lot of cases where in a closed area like a warehouse or a smart mining area, you want to see where are the employees right now, where is the task force, where is the labor deployed, if a labor is going into unauthorized areas, or if a labor is going into mines which are shut down, or if there are sensors deployed in the mines which can detect poisonous gases leaking. So those are very interesting use cases. In smart homes, of course, there are smart appliances. You also need to see probably what's a crowded vertical versus what's a new kind of use case which has not yet been explored. So a lot of opportunities. You will need to clearly figure out a strategy on how to not only invent solutions but also sell those solutions. Um, the third question again from Vatsal Shah. For two-way communication from gateway to device, is it better to choose LPWAN? Well, LPWAN just for two-way communication, a lot of technologies support two-way communication. Of course, GSM supports that, Wi-Fi supports that, Bluetooth supports that, LoRa as well supports that. So it's again a use case based strategy. A question from Amrit Kumbhakar. I am looking for a gateway with high robustness along with low cost. Can someone suggest? Well, if your question is specific to LoRa, please connect with us and I'll be happy to suggest to you vendors that we closely work with. A few famous companies are Curlink, Multitech, Tectelic. Then there are other companies who are Chinese or Taiwanese manufacturers. Um, like Rising HF. Uh, then there are several manufacturers out there, and it's usually a case of what's the price point. You can even start looking into making your own gateways for LoRa, and that's also feasible with off-the-shelf component purchase. I'm going to switch over to a question from Shuk Saxena. He's asking, how can we benefit from IoT in healthcare? Well, good question. The use cases in healthcare are tremendous, and there's a big opportunity out there. IoT in healthcare can be benefiting a patient. It could be benefiting an IT infrastructure team that sits in the hospital. It could benefit to track assets inside a hospital. So you have several expensive piece of machinery or equipment going from ward to ward, going from operation theater to operation theater. A lot of assets being passed around in the hospital. If you want to track that, if you want to check the energy consumptions of MRI machines, you want to do predictive maintenance on them. You want to be able to check the patient health data, like patient blood pressure, patient sugar levels or oxygen levels, or you want to really check out abnormalities in the patient heart rate, SpO2 levels. So several use cases possible. One thing you should consider while venturing into the space is this is a highly regulated space because you're essentially playing with people's lives, and the kind of certifications, regulations on RF like FCC or CE certifications mandatory, or the kind of collection of data and data privacy. These things have to be really closely accounted for, and you should, before entering the market, make yourselves very sure on the regulatory authorities' permissions. I'll move on to the next question from Akshay Ramanlal. Is anyone has deployed LoRa network here in India? Yes, us, SenRa. We have a presence in 16 cities in India right now. It's covering a lot of major cities as well as tier 2 cities. And we'll be hitting a 30 city mark by the end of this year. And by the end of 2020, we'll be trying to hit 100 city mark. You can go to senraco.com, our website, and check out our deployment. You can just enter your PIN code and see if you have an existing network in your area. As simple as that. One more question from Apparaju. Can LoRaWAN be run using general router, or else it needs any other router? Well, LoRaWAN can only be run on LoRaWAN specific routers, and you can leave that part to SenRa. You can leave. You just want to come up with your own device solutions and talk to SenRa to get a network at your preferred locations. The next question is from Janki Raman. Hi, what is the best training to get started in IoT career? Well, IoT, it's a question I hear a lot, and there are a lot of components within IoT. As I discussed, you could be an expert in embedded devices. You could be an expert in developing embedded hardware. You could be an expert in running the algorithms on those embedded devices. So a lot of verticals within the device itself. You could be an RF level expert, like antenna expert, or a protocol expert who knows a lot about 6 LPAN or constrained application protocols, or Zigbee, Wi-Fi, Bluetooth. A lot of different kind of verticals available within the device ecosystem. Then you could come to a network infrastructure where you could be an expert in new technologies like LoRa or existing technologies like GSM, Bluetooth, Wi-Fi. You could also be a data expert. Lot of companies are now having these analytics platform, which is generic but specific to IoT, but generic for use cases. So a good way to start is probably identify your skill set, your current skill set, and match it with where you want to be 2 or 3 years from now. And start with free online training material. A lot of companies now offering IoT use cases like Coursera, MOOCs, being offered for free and for specific certifications if somebody wants to go for them. So yeah, it essentially is your call at the end of the day. A question from Anand Tiwari: how do we test our solution using LoRa? Well, as I said, start with purchasing a kit from ST Microelectronics or Arduino or Raspberry Pi. Plug in a small IoT LoRa chipset. It could be an AC-SIP chipset, microchip. So there are several vendors out there. STM has their own. Murata modules, So several kind of solutions out there. Use jumper wires to connect your Arduino kits to these evaluation boards. Download the stack from GitHub for LoRaWAN and use our network. Enter your location pin code at our website. See if you have an existing network coverage. And if you have one, well, you go to portal.senraco.io. I'll just broadcast this portal link just in the interest because I'm getting a lot of questions around this. So I've sent it to all. So you can just log into this portal and there is a documentation available at docs.senraco.io where you can read on how to start using the network. Okay, if that, yeah, that essentially brings me to the end of all the, no, okay, there is several others. So in the interest of time, I will have to selectively pick up questions and I'm sorry if I'm leaving your questions aside. So what's the difference between LPWAN and LoRa? A question from Praveen Kumar. LPWAN is a generic term and it encompasses LoRa, Sigfox, Ingenu, Weightless P, NB-IoT, which is coming up soon. So a lot of different kind of technologies within a low power wide area network. LoRa is a specific technology, one of those technologies, and it's a MAC layer. LoRa stands for the physical layer. LoRaWAN stands for the open standards around LoRa. And LoRa essentially is a specific kind of modulation technology. It's a type of FSK called chirp spread spectrum. And you can start digging into details of what specifically LoRa is. The original inventor or proprietor of this technology was Semtech, which is a French company. So yeah, start looking into what LoRa is, but essentially it's a subset of LPWAN. A question from Mayank Saxena. Let me just check how many questions. This seemed to be a lot of questions. I'll quickly start going through questions in the interest of time. So a question from Mayank Saxena, which microcontroller is best suited for this technology? As far as I know, we use different device microcontrollers for capturing sensor data and different device for processing the data. Are we using something which can do both the things in one-stop shop? Good question. Seems like you have a fair bit of experience using this. Yes, there are, to answer your question, yes, there are single stock solutions which incorporate a microcontroller as well as a LoRa chipset. There are several device manufacturers out there doing this. There are devices from Microchip. There are devices from ST Microelectronics. There are chipsets, modules as well as chipsets from AC-SIP, which is a Taiwan-based vendor. So several others. What I would suggest you to do is get in touch with me directly. My email address is kush@senraco.com. I'll quickly type that out so everyone has access to that. Shoot your queries to me, and I'll be happy to connect you with relevant partners which we work with. A question from Abhishek Mai. Do we get security protection with LoRaWAN connections? Yes, so good question. Several layers of security. The security lies in the fact that the device confirms whether it's talking to the right network or not. The network also tests whether the right devices are talking on its network or not. So there is a key exchange that happens then. There is also an application level confirmation. So which data packets can speak to which applications, and whether an application can decrypt the data or not is also monitored. All this data is AES encrypted. Obviously, there are third-party security agencies that can key in a small key for a particular device, and whenever the device tries to communicate, they validate this key, whether that's the perfect key or not. So several layers of security available. Um, and just get in touch with me. I'll be able to explore more with you, and I'll be able to explain more to you later on. How much rate LoRa on security aspect considering it is open source? This is a question from Rohit Soni. Um, Okay, so the open source doesn't mean the security is compromised. The open source means that anybody could get the device stack and start playing around with solutions. The security is inbuilt in the stack. So when you start communicating using this stack, you will have to use application session keys, network session keys, which are specific to a session. Then you have the app key, which is specific to a device and an application. You also have AES encrypted data. You also have device storing particular keys which authenticate a device itself. Several things that go in the background of this open stack. Hope I answered Rohit's question. A question from Alok Tripathi. Could you please share the web link for LoRa application on GitHub? Please write to me on my email and I'll be happy to share that link with you offline. Question from Shubh Saxena. I want to work on IoT in healthcare. I want to create a network where I want to plant temperature and moisture detector for letting farmers. That's not healthcare, but okay, anyways. For letting farmers know what the crops need, example water. I also want to put forward a check of pH of soil. How can I perform the task? There are professional pH probes available. You can check out a company called Atlas Scientific. You could take in ready-made sensors. These could be industrial level sensors or lab setup sensors, depending on what kind of accuracy you want, what kind of drifts you want, or calibration requirements. Connect these devices to your Arduino kits and connect an external LoRa module with your Arduino kit and start sending all this pH level sensor over a LoRa network. That would be a good place to start. You could also use you could also use soil humidity and temperature probes. Then we have ready-made solutions available. If you are interested, if you want to make your own solution, please write to me and I'll be happy to connect you with sensor manufacturers also. Okay. So last 3 questions I'm going to take it up. Question from Janki Raman. Can you please specify what all aspects to be looked at, like embedded C, Java, Raspberry Pi, while taking a training on IoT? Note I have 10 years of experience and want to change my professional career to IoT domain. If you could have told me what was your past experience about, possibly that could help you into deciding where you want the next career path to be in. A good place to start off with and a cheap way to get started is buy an Arduino kit and start with embedded solutions. An Arduino kit would help you write easily applications on C, and it's an easy to use developer friendly ecosystem. You'll get a lot of development forums where a lot of different problems are discussed, so you'll have easy support. And of course, at any point of time, if you get stuck, write to us. Question from Anand. I'll combine the 2 questions. How do we test our solution using LoRa? Well, connect to our network, start seeing your data on the portal that I just gave a link previously to, portal.senraco.io. How do we test? How do we use LoRa in waste management? Well, okay, so how do we use IoT in waste management, recycling of plastics and recycling of waste? How we can offer waste management using IoT in smart city or smart town? You could detect fill level of a waste bin. You could detect the poisonous gases that emanate from a solid waste management site. and you could really detect what kind of methane is generated, what kind of carbon monoxide is generated. When the waste pile decomposes, the temperatures of the waste pile also rise. So you could detect what's the lifetime of this waste pile based on the temperature. Lot of various, start reading white paper research and start reading through uh, white papers, existing solutions, and you'll be able to find your niche product offering. Last question from Apparaju. Actually, I'm working on microbios, artificial white blood cells. Oh, okay, that's cool. Which need to be integrated with IoT. Can it be possible in micro ranges to assess successfully without disturbing the other part stimulus? A very interesting question. I think you are working on very niche product offering. I would suggest if you could connect with me offline. If you have an existing sensor system, transmitting this over an RF network is not a problem, but it totally depends on how you are sensing, um, how you are getting this data from in the micro ranges, and if it's accurate enough or not. I understand your question. Probably when a sensor is trying to get that data, a lot of electricity is passing through the system, and that might disrupt the data itself. But connect with me offline. I would like to understand where this use case is coming from, and if possible, I'd like to work with you on developing, the device. So happy to answer questions offline from now. Over to you.
Thank you so much, Kush, for this really empowering and motivating session today. I would also like to thank all our participants for making this webinar a great success. The session has been recorded and the recording will soon be available on techgeek.com. Thank you everyone for joining us.